Okay, so Assalamu alaikum wa rahmatullahi wa barakatuh. Once again, today we are going to start session number 3, which is going to be about analysis and bending moments of for solid slabs. Okay, previously in theory of structures 1 and theory of structures 2, you have learned how to do the analysis for mainly the framing elements, talking about the columns, talking about the beams, and then you have taken the trusses as well. Right. Have you started analyzing slabs? Did you do any type of analysis for slabs in terms of bending moment and shear force? Any person? Once again, keep it interactive so you will not feel bored and I will not feel bored as well. Okay, so whatever I assume, whatever you have taken in terms of slabs, were related to something called deal line, in which you have understood how the slab is failing and how the slab is divided into different areas. Okay, according to the number of beams surrounding the slab, or number of supports supporting that slab, if it's a flat slab or any other type of slab. Now, in today's lecture, we are going to go deep in understanding how we are going to do the analysis, in which we refer to bending moment and shear forces. Okay. Now let me just open for you the screen. Are you able to see the screen? This has been uploaded for you since yesterday, the presentation, yesterday midnight.
Yes, Mister.
Okay. So now if we go and see, once again, the session is named Analysis of Bending Moment, Analysis and Bending Moment of Solid Slabs. So we are going to learn how to understand the behavior of solid slabs, how to find the bending moments, and then later, after we will be able to get the final bending moments, we'll be able to design. So without finding the bending moments, without understanding the behavior of slabs, you will not be able to find the reinforcement. Now, mainly there will be two sections or two divisions of this particular lecture. One is going to be structural analysis of slabs, and then after basics of structural analysis for slabs, and then we are going to do or check how to calculate the bending moments for slabs. Okay. Now, once again, I'm just repeating. Whenever you get the internal forces for any element, designing it won't be a problem. If you are finding the bending moment and shear forces, you will not have a problem in designing the element. The problem is in finding these internal forces. You have already an equation which is AS is equal to M divided by 0.95 Fy into Z. So if you get your M value, you will be able to determine the quantity of reinforcement required. The most important thing that you need to know how much is the internal force, and accordingly you will design how much reinforcement is required to resist this particular bending moment. So if we see, the first thing we are going to discuss is the structural analysis for one-way slab. Now, can you see here that we have a one-way slab, which is like having two different arrangements? Can you see? Can you see that the left slab is a single isolated slab? It's a single slab, and the second one is a slab which is surrounded by other slabs. Can you see the picture?
Yes.
Okay, so if we are assuming that this is going to be a one-way slab, and how to know whether the slab is one-way or two-way? You will know whether the slab is one-way or two-way by calculating the longer span by the shorter span, which is Ly divided by Lx. If your Ly over Lx is more than 2, then this turns to be a one-way slab. In short, if you have in your slab one element to be very long and the other element is relatively short, then it tends to be a one-way slab. Okay. If somehow the dimensions are close to each other, then of course it's going to be a two-way slab. Now, if you see, one-way slab will bend majorly in how many directions? Do you remember when we have talked about major bending and minor bending in the previous session? We said there is major bending and there is minor bending in one-way slab, and we said in two-way slab there are two major bending. Do you remember?
Yes, Mr.
Okay. So which side normally? Yeah, it bends majorly in one direction. It bends in the other direction, but the bending is going to be very small. Okay. Now, in which direction we design normally? The bending will be happening in which direction?
Short direction.
Short direction. Okay. So if we take the short is going to be parallel to your Lx, right? So I'm going to draw a line here which is parallel to Lx, and I'm going to draw another line here for the second one, which is parallel to Lx. Are we clear? Are we clear?
Yes, Mr.
I have drawn a line in the slab, okay, representing Lx. Now, if you see in the first scenario, let's call this one to be scenario number A and this one scenario number B. Now, in scenario number A, we said the slab will be supported by what? Here, or the slab here is supported by what? You can see that the slab is supported by one beam here and another beam here, right? And then the slab here is supported by a beam and is supported by a beam here. Are we clear?
Yes, Mr.
Now, how many slabs are there? How many types of supports? Sorry, how many types of supports are there? How many types of supports are there? No, not in the pictures. I'm talking in general. How many types of supports are there?
Six.
How many? In general, once again, how many types of supports are there? I'm not talking about these two pictures now. You have studied that we have a hinge, we have a ruler, and then we have a fixed support, right? If you remember, hinge, ruler, and a fixed support. Okay. Once again, hinge, ruler, and then a fixed support.
Fixed.
Okay. Now, when it comes to RC design, or when it comes to real designing, especially in RCC, we shouldn't call them as hinge, ruler, and fixed. Okay. We are going to be, rather than calling them these, we are going to call them continuous, and non-continuous. Okay. So we have a continuous support and a non-continuous support. If your support is continuous only from one side, if it's continuous from one side, it's called to be non-continuous. If it's continuous from both sides, then we are going to call it as continuous. Okay. Now, what do we mean by continuous and non-continuous? Okay. Now, if you see this particular slab, okay. Now, if I draw this support here, do we have another slab on the right side? Do we have a slab on the right side, or there is no slab?
No slab.
On the left side?
Yes, there is slab.
Okay. So since it's having only one side, we call it to be non-continuous. It does not have any continuity of slabs. Okay, it is continuous only for one side, so that particular support is called non-continuous or discontinuous. Okay, so we have non-continuous or discontinuous, they are the same meaning. Now in this scenario, if I try to draw a support, do we have a slab here on the right side?
Yes.
Do we have a slab on the left side?
Yes.
Okay, so this particular support is considered to be a continuous support. Okay, so we have a continuous and we have a non-continuous. Now if you see, just to keep it easier for you to relate, we are going to try to draw a free body diagram, or whatever we called it yesterday as, or last class, as idealization. Now you can see what I have done. I have drawn a support here, and I have drawn another support here, since this is my element. Now I didn't do any continuation. There is no continuation here. There is no continuation here, because this support is considered to be non-continuous or discontinuous. Why it's considered to be discontinuous? Because we don't have any other surrounding slabs. Are we clear about that thing? Are we clear about it?
Yes, Mr.
Yes.
Okay. Now for the other side, once again there is a support here, there is another support here, but we have another slab. So in order for us to represent the slab, we are going to extend. So we extended a certain portion here, and we have extended a certain portion. Okay. So that's what you are saying in case number A, and this is what you are saying in case number B. Case number A does not have any surrounding slabs, so it's only one span with two supports. The free body diagram, or the idealization for the second scenario, which is scenario number B, we have one span, two supports, but we have other spans on the right and the left representing the other slabs. Are we clear?
No, Mr.
Okay. What is the part which is not clear?
When you add the portion, Mr.
When I add what? The support, you mean? Or the portion?
Yeah, the extra.
Okay. Now if we take, let us call this one case number 1, and this is case number 2. So for case number 1, what I need to draw when I draw the free body diagram or the idealization, I need to draw a line. So there is only one slab. It means there will be one line. Now this slab is supported by a beam, so there will be a beam here, and then there will be another beam here, since there are two supports. Is it clear for this case number 1?
Yes.
Okay. For case number 2, there is a slab here, so I have drawn a line. There is a support here because of the beam. There is another support here because of the beam. But what happens? You can see that there is another slab here. Can you see that there is another slab? And here there is another slab.
Yes.
Now it is like this. If we want to extend it, for example, it is going to be like this. If I want to draw the what you call the idealization for this area, if I want to draw the idealization for this area, then it's going to be a span here with the two supports, then a small extension, and then a small extension. Right? To make it a bit clearer, what I'm going to do, there is a support here, there is another support here. Do you agree? Do you agree if this is the slab?
Yes.
This is the second slab. Okay, and then we have the third slab here. Do you agree that there are three spans? Span number 1, span number 2, span number 3. Do you agree that there are three spans?
Yes.
Yes.
Okay. Now what happens? I don't want to draw for the full thing. My drawing is only for this part. So if I want to take the drawing for this part, I'll just cut it from here. Now if you cut from here, what will you see? I will see a span supported by two supports, and there is a small extension on the side. Is it clear?
Yes, Mr.
Extensions are representing the slab on the other side. If there is a slab, you need to draw an extension. If there is no slab, no extension. Are we clear? If the support is continuous, there will be extension. If the support is discontinuous, there will not be an extension.
Yes, Mr. Clear.
Okay. Now going here, you will see what we have done. We have tried to draw the idealization. So in the left side, or case number one, in case number one, we are having one span and there are two supports. These supports are discontinuous because we don't have a slab on the right, we don't have a slab on the left. Okay. Now if we see the second scenario, you can see that we have a span. There is two supports, but these supports are continuous. So I need to have an extension on the right side since there is a slab, and then I need to have an extension on the left side since there is another slab. Okay. Now after we understood the free body diagram or the idealization, drawing the bending moment wouldn't be a problem. Okay. Now the loading in the slab is normally uniformly distributed. Now if you are having a uniformly distributed on a strip or in a span which is having two supports only, you will end up having a bending moment of the shape. Do you agree? Do you agree that this is going to be your bending moment?
Yes.
Okay. Now for the other scenario, once again, there is a loading on this slab and there is a loading on the other slabs as well. So now if I want to do the bending moment diagram, what I need to do? Okay. Now to keep it a bit easier for you, all the bending moment diagrams or the basic bending moment diagrams are a combination of either simply supported supports or a continuous support or fixed, whatever we call it as fixed. Okay. Let us call this one to be simple or discontinuous, and let us call this one to be continuous. Okay. So this is discontinuous. Okay. Now what happens if I try to draw a simply supported case? In simple discontinuous support, the bending moment is going to be equal to 0. So 0 is 0, and then due to the fact that we are having a UDL, you will see that it will bend as a parabolic profile. Now, continuous is representing either by a fixed or by a support which is continuous from both sides. Okay. Now, if you see, if I have done this thing for you, or this type of element for you, you will see your bending moment will go up. Okay. You will see that your bending moment will go up, and then it will lead to go to 0. Do you agree with these basic bending moment diagrams? Are you
Yes.
agreeing with these basic bending moment diagrams? Okay. Now, so what I understood if we are having simple support, the bending moment is equal to 0 at the support. And what I understood as well, if it's continuous, then we are going to have a certain value of bending moment at the support. Are we clear about this basic thing? Now, since this is a fixed support, it is going to be continuous only from one side. Okay, it is continuous from one side. Okay. Now, if we are having an element, which is acting in this way. Now, can you tell me this support, is it continuous or discontinuous? Is it connected from both sides or one side only?
Discontinuous.
From one side or two sides?
One side only.
One side only, so it's going to be discontinuous as we have said. What about this one?
Same.
Same. What about these two?
Continuous.
Continuous. Okay, so when we try to draw the bending moment diagram, when I try to draw the bending moment diagram, you will see that the bending moment at this point and this point are equal to 0. Why? Because the support is a discontinuous support. Now, for this particular part and this particular part, it's discontinuous. Now, is it discontinuous like the fixed from one side, or is it continuous from one side like the fixed, or is it continuous from both sides? These two supports, let's say B and C, are they continuous from both sides, left and right, or only single side?
Both sides.
Both sides.
Both sides.
Okay, so they act as a cantilever from the right side, and they act as a cantilever from the left side. So how we are going to do it? We are going to draw a small cantilever here. We are going to draw a small cantilever here, representing this continuity, and then once again a small cantilever on the left, a small cantilever on the right, since it's continuous from both sides. And then when we try to draw the bending moment diagram, your bending moment diagram will go in this way. Are we clear about our bending moment diagram and how to draw it?
Yes, mister.
Okay. Now, if we go back to our drawing, now what we can understand from here, we can understand that we are having two supports which are continuous, right? Are they continuous from both sides in case number 2? For case number 2, supports are continuous from both sides, right?
Yeah.
Yeah.
Yes.
Okay, so we are going to draw our triangles. We are going to draw our triangles, and then we are going to connect these two by a parabolic curve. Are we clear?
Yes.
So now if we want to see, now in case number 1, how many moments we have? Is it only positive or is it only negative?
Negative, sir.
Negative, Master.
If it's going down, is it negative? Bending moment, if it goes down, it's going to be negative.
Yes.
Okay. So normally if the bending moment goes with the gravity, it's going to be positive, not negative, and this is going to be called as mx positive. Okay. Why x? Because it's representing the show. Once again, in one-way slab, we calculate only the bending moment, which is for the major side, which is for x. It is going down, so it's going to be positive. Now, in case number 2, do we have negative and positive here?
Yes,
Yes,
mister.
mister.
Okay. So for this part,
Continuous.
the bottom part, we are going to call it as mx positive, and for the top part, we are going to call it as mx negative. Are we fine? Are we okay?
Yes.
Yes,
So
mister.
in summary, for case number 1, there will be only one moment to be calculated, which is mx positive. In that scenario, you used to calculate it as WL square over 8 if it's uniform. The other scenario is wherever you are going to be having either 2 mx, which is mx positive, and mx negative. Mx negative here can be different from this value as well. It depends on whatever arrangement of slabs you are having. Okay. Now, in short, this is going to be the bending moment diagram for both scenarios. Do you agree? Do you agree that this is going to be the bending moment diagram for these scenarios?
Yes.
Yes, mister.
Okay, now this is for a one-way slab that you have studied. Now going for two-way slab. Okay, and I'll try to be quick here. So we have once again a two-way slab, which is simple. I mean, it's not connected to something else. And then we have a two-way slab, which is connected to the other slabs. Now, if we want to draw, now instead of having one major bending, we are going to have two major bending. So it's going to be a line here. There is a support here. There is a support here. And the other side, we are going to have a line here, where we are having a support here and a support here. Okay. Now, if we draw a line for the other scenario, which is scenario number 2, I'm going to draw a line. There is a support here. There is a support here. For the other side, there is a line here, and we have a support here and a support here. Are we clear about the idealization and free body diagram?
Yes.
Okay. Now, if you can see, this is going to be the first side, which is representing X. Parallel to X means representing X, which is this one. And then we have, for the second scenario, we have this one. Okay. Now, the main difference between one-way slab and two-way slab, as we said, one-way slab will have major bending in one direction. Two-way slab will be having major bending in two directions. So now we will not have only one drawing to be drawn. We are going to have two drawings. Okay. We are going to have two drawings. Okay. Two drawings. So unfortunately, there is something missing here. But anyhow, the other side will be having as well something similar. And then here you will be having something similar like this. Okay, so both sides will be there. Now, if you see the bending moment diagram, since this is discontinuous from both sides, it turns to be a simple action or a parabolic, regular parabolic. The other side as well. Now, this is since it's for X, then we call this one as mx positive. And then since this is representing or parallel to Y, then we call it as my positive. Okay, so this is what you can see. One is msx, one is msy. Okay. M is moment, S is span, X is short, Y is long. Okay, the other side as well, it goes in the same way that we have done. So we will go up here, and then it goes down. So the same thing you can see here, the same thing you can see on the other side. Okay, are we clear? Is it clear about this point?
Yes.
Okay, so
Mister, it is same, right? Same
Same of-
one way, but there is only Y, my added.
yeah, this is what we said. The main difference between a one-way slab and a two-way slab. In one-way slab, you will have one major bending. So there will be one side drawing only. In two-way slab, there will be two major bending, means you need to calculate for both. For example, if you are talking about this case, then you need to calculate two bending moments. One is for Y, one is for X. And then you need to calculate two reinforcements. One is for X, one is for Y. Now, in this scenario, you have how many bending moments? You have 4 bending moments. You have Y positive, we have Y negative, we have X positive, and we have X negative. Do you agree? Do you agree?
Yes.
Okay, so it means how many moments will be there? How many moments for this scenario?
For the two-way slab.
For this two-way slab, how many moments are there?
2.
There will be 4 moments. 2 for Y, 2 for X. For Y, 1 positive, 1 negative. For X, 1 positive, 1 negative. So how many moments? 4. If 4 moments, then how many reinforcements? If 4 moments are there, how many reinforcements are there? For each moment, there will be 1 reinforcement, right? For
Oh.
each moment, there will be 1 reinforcement.
Yes.
Okay. So now, is it clear for you the difference between one-way and two-way and how to draw the bending moment before we proceed further?
Yes, Mr.
Are we okay? Okay. Now, can you tell me how would you do? This was one of the previous exam questions I have wrote in quiz 1. Can you tell me how would you draw the bending moment diagram for this case? Any person? Any person who can help me here?
There is, Mr. This one-way slab. Huh?
Okay, so
No, there is only X direction of moment.
then
We'll draw span.
okay. How many drawings first you will draw here? How many options are available?
4.
4 options.
Yes.
Now, to make it a bit easier, as your colleague said, it's a one-way slab. If you divide 8 divided by 3, it will give you something more than 2. So your drawing is going to be only majorly in one direction, which is the short. The short is going to be represented by the 3. Okay. Now, the question asks to draw the bending moment for the slabs, not for a single slab. Now, what I need to do, I need to draw strips of lines or strips of slabs. So I'll draw a first line here. Now, if I draw this line, okay, how many supports are there? For this line, how many supports are there? For
2.
this strip of
2.
span,
2.
2 supports. Discontinuous or continuous?
Discontinuous.
Okay, discontinuous. So if I want to draw the bending moment, my bending moment is going to be this part. Are we clear for that part? Are we fine?
Yes,
Yes,
Mr.
Mr.
Okay. Now, if I draw another line here, for example, if I draw another line here, will it be different from case number 1, or is it going to be the same?
Same.
Same. So no need to draw another strip over there. Okay. 1 and 2, if you can see, they are going to be representing the same thing. So no need for you to go and draw a strip in part number 2. Are we clear?
Yes, Mr.
Okay. Now, if I draw here, if I draw a strip now here, is it going to be the same as 1 or 2?
No,
No.
No.
it will be
So this
continuous.
So this is going to be my second case now. First case, it was only single strip of slab where it has 2 supports which are discontinuous. Now what we are having now, we are having first support, second support, third support, fourth support, and then fifth support. How many discontinuous?
3.
2.
How many
Mr.
discontinuous? Discontinuous are the ones outside. If you see,
2.
this support and this support are having continuity only on one side. It means they are discontinuous. We don't have any other slabs on their other side. Okay, so the bending moment here goes 0, here goes 0. Here we said we will go up, so I'm going to go up, once again up, once again up, and then going to 0. Are we clear? Are we fine?
Yes. Yes.
Okay.
Yes.
Okay. Okay. Now, if I draw another line here,
Sir, I have
will
a
it?
question, please.
Yes. Tell me.
Why you start from one left side from the first support?
You can draw even from the right support. That's fine. The drawing will never be the same. I mean, will never change.
Okay, thank you, Mr.
Okay. Now, if I take another line, now here, if this is 3 and this is 4, 4 and 3, are they different or the same?
Same.
The same.
Same. So no need to draw 4, right? Now,
We
if I
draw it
draw
down, Mr.
if I draw here,
or support,
if I draw here now,
it will be different.
it will be different, right? So now, once again, this is a support, this is a support, this is a support, this is a support. So 0, since it's discontinuous, 0, it goes up, and then it goes to 0. Are we clear? So the solution for this particular question, that the student should have drawn 3 drawings. One is for this strip, one is for the second strip, and the third is for the third strip. Are we clear?
Mr.
Yes.
In case number 5, the left support is continuous.
Which one?
In case number 5,
In case number 5, yes.
the
Which
left
support?
support, the left
This one?
one.
This one?
Yes. Yes.
Do we have any slab here?
What about that one on the?
Which one?
Okay. I get it.
Okay. Okay. Others, is it clear? Others, is it clear?
Yes,
Yes,
Mr.
Mr.
Yes.
Very good. Okay. So now, before going to here, let us go to one problem I'll give you. This is another exam question that I used to bring. How you will do for this case? There are 3 drawings given to you. And the question says, draw the bending moment diagram for me. Okay. I think this was the 3 marks question.
For the
Let
first
us
one,
say,
it will be one-way slab, so there is one span.
okay. Okay. Let us modify it slightly, so it will be more challenging. This is how it was before changing it. Now, case number 1, case number 2, and case number 3. For case number 1, is it a one-way or a two-way slab? 7 divided by 3, is it more than 2 or lesser than 2?
One way slab, Mr.
One-way slab. 7 divided by 3 is more than 2. Once again, 7 divided by 3 is more than 2. So it's going to give you as a one-way slab. One-way slab, you will be drawing the bending moment in which direction?
X direction.
In the shorter direction, right? In the shorter direction. So when I'm going to draw the bending moment, my bending moment will be like this, and this is going to be the shape of the bending moment diagram. Do you agree?
No,
Tell me why.
because it will be minus. It should be positive moment.
How did you
Should be down.
know that this is how did you know that this is positive or negative? If this is only a strip. Can you rotate your laptop and check whether it's positive or negative now? If I have drawn my support here.
Depend on support, no, Mr.
Okay, so if now is it positive or negative?
Yeah, positive. No,
So it depends on how you look at it, right?
depends on support, right?
It depends on how you look at it. You look at it from which side, or where is your free body diagram. Now for second scenario. Second scenario. Two-way slab. Since the second dimension has not been given, it means the first dimension, second dimensions are the same.
5 by 5.
Right? If one dimension has been given only, it means the second dimension is the same. Do you agree?
Yes.
Okay. So if it's 5, then the other dimension is 5. Now 5 divided by 5 will give you 1. Is it one-way slab or two-way slab?
Two-way, Mr.
Two-way.
Two-way slab. For two-way slab, we are going to have two drawings. Do we have any continuity? Is there any other slabs on this side? In any of the sides?
No.
No, Mr.
Oh. So now my drawing for the first side is going to be on this way, and the other side it is going to be on the other direction. Are we fine? Is it fine?
Yes.
Sir, you can repeat?
Yeah. So this is a strip. Here we have taken a strip. There is a support. There is a support. So this is your bending moment. We have taken this strip. So this is my line. There is a support here. There is a support here. And this is going to be my bending moment. I combine the two in one row. Are we fine?
Yes, Mr. Thank you.
Mr. In case number 1, it's continuous or not continuous?
Now, when you see the shorter side, is it continuous or non-continuous? The line which I have drawn here, the line which I'm drawing now, is it continuous or discontinuous?
No, Mr. Not continuous. I mean.
Okay. Yeah. So
But
discontinuous.
Mr. How about the other slab? Why you
Which
didn't
are,
the left side, the slab
okay.
which have a left side? Why you didn't draw the sketch on it?
Because it says for you slab, it has been mentioned that this is the slab to be drawn for.
Okay, thank you, Mr.
Third one, third scenario. Third scenario.
Two-way slab, Mr.
Okay, so actually, this question, the students were asked to calculate or to draw the bending moment and then find the coefficients. I'll explain for you after drawing this what's the meaning of coefficient. Okay. So what about case number 3? Or let us go before the coefficient, or before drawing for case number 3. The coefficients normally, or the typical bending moment equation, is written in this form. That normally it's beta into n into Lx square, or instead of n we can write it as W. Okay, so beta, which is a coefficient, multiplied by W multiplied by Lx square. Are we fine? This is the typical equation of bending moment. Coefficient multiplied by a unit of loading multiplied by a square of the critical dimension, which is x. Now in this scenario, since it's one-way slab, the bending moment is known to be WL square over 8, right? Since it's for case number 1, since it's a one-way slab and it's discontinuous, it's known that it's going to be WL square over 8, right? If we rewrite this equation, we can write it that it's going to be equal to 1 over 8 multiplied by W multiplied by L square. Can I do like this?
Yes,
Yes.
Mr.
Okay. So this L square is the same as this Lx square. This W is the same as W. So in this case, my beta is equal to how much? The coefficient of bending moment here is equal to 1 over 8. Do you agree?
1 by 8.
So coefficient is the value that you see before before each and every equation of bending moment. WL square over 10, WL square over 12, WL square over 24. These are representing the coefficients. The values are representing the coefficients. Are we okay?
Yes, Mr.
Now, since this is a two-way slab, we'll come to the coefficients later, since you didn't study. Now, for case number 3, is it a one-way slab or a two-way slab?
One
So-
way.
One way.
Huh?
One
One
way
way. Okay, how to draw the bending moment in this scenario?
with 3.5 with the X-axis.
Okay, so what we are going to do, the x-axis, so it shows the direction, is 1.5. So my drawing is going to be on this side. Do you agree?
Yes.
Yes.
Okay. Now, do we have a support on the other side? Do we have a support here? Is there any beam shown?
No.
Do we have any beam here?
Yes, yes.
Yes, Mr.
The blue color is representing what now? Can you see that these are columns?
Yes.
And can you see that there is a beam connecting the columns?
Yes, the blue one.
The blue one. So in this side, do we have a beam?
No.
Do we have a beam here? Do we have a beam in this area?
Yes.
Yes, Mr.
Yes.
Okay. So now to draw the bending moment diagram, it's free from this side. The other side is going to be acting as a fixed support. So this is a cantilever slab. Are we clear?
Repeat, Mister, please.
Okay. So how to draw the cantilever slab bending moment? Same. It goes down in this way. What is the equation for bending moment for a cantilever?
W.
WS minus over 2.
So WL square over 2. What's the coefficient of bending moment?
Half.
Half.
Half. So beta is equal to half. Okay. So once again, what we have learned, it's very important for you to know the type of slab, whether it's one-way slab or a two-way slab, in order for you to know how many drawings to be drawn. After knowing which type of slab, you need to analyze whether it's going to be a discontinuous, continuous, or a cantilever portion. And accordingly, you can find your bending moment and then the coefficient if it's one way. If it's a two-way, then you need to use the tables to find the coefficients, and we are going to see now. Okay? If we go and see here, so this slab, is it a one-way or two-way? This slab, is it one-way or two-way?
Two-way.
Two-way slab. Two-way slab. Okay. Now for two-way slab, if we open our BS code, I have already uploaded for you the BS code. So if you open your BS code, now you can see that I have uploaded for you extracts as well as belief. Extracts are the summarized part. Okay. Now if you open the extract, there is a table of contents which shows you a lot of things. Okay. Whatever things that you will be required for this particular course. Durability requirements, effective length, continuous one-way slab, and then we have two-way slab. Can you see here slabs? Can we see the chapter of slabs? Are you able to see?
Yes, Mister.
Yes.
Okay, so we have slabs, and then we have continuous one-way slab, and then we have simply supported two-way slab, and then we have two-way continuous slab. So I'm just clicking on slabs. Now you can see there is a continuous one-way slab, and in continuous one-way slab you have studied this table in design of structures 1, if you remember, where it was first interior, middle interior, or interior, and then interior. You have first interior, outer support, interior support, and then you have middle interior span, and then you have end span. Do you remember this? Whatever you have done in your design of structures 1?
Yes, Mister.
Yes, Mr.
Yeah, okay, good. Okay, so that was one-way slab. Now in two-way slab we have two types. We have one which is simply supported, and we have one which is called to be restrained or two-way continuous slab. Okay. So further, there are two types of simply supported. One is, of two-way slab. One is simply supported. Another one is restrained slab. When I say restrained, what's the meaning of restrained? What's the meaning of restraint in English?
It's like a bridge.
No. Restraint means,
It's fixed. The meaning.
restraint means connected or fixed to something, or hold in position. Okay. Now, if we say, now there are two types of construction normally. We have a precast and then we have a cast in situ, right? You have studied this in materials, I believe. We have precast and then we have cast in situ. Precast is done in factories, and then cast in situ is done in the site directly. So when we are talking about the precast, are the elements going to be connected to the other elements, or they will be constructed in the factory and then they will be taken to the site?
In the factory and taken to the site.
Okay, so they are not connected to something. Okay. If your element is not connected to the other element, the connection here is assumed to be simple connection. Means these two elements are not connected together. The first element is only sitting on the other element. Are we fine? Second type, you will see that no. If you are doing a cast in situ, what will happen? You will see that your elements are connected to the other elements because the construction is done in that way. Do you want me to give you an example so you'll understand the difference between simply supported and restrained?
Yes,
Better.
better.
Better. Okay. Now let's say that I have a chair. Okay. I have a chair and I had two scenarios. Scenario number one, I sit in the chair, or I sat in the chair. Scenario number two, I put a glue and then I sat in the chair. Two scenarios. Scenario number one, I sat in the chair. Scenario number two, I put a glue on the chair and then I sat. Now, scenario number one, when I'll get up from the chair, will I still be connected to the chair?
No.
No.
Once again, first scenario, I was sitting in a chair and then I got up from that chair. Is there any connection between the two elements?
No.
No, you are only simply sitting on the chair. So you are acting as a simply supported. You are supported by the chair. There is no connection between both of you. Are we clear? Now, if there is a glue and I was sitting on the glue, now what will happen when I try to stand? You will see that the chair will try to restrain me. It will try to hold me. Right? Still, the chair is still connected to me
Yes.
because of the glue, right?
Yes.
So when we talk about simply supported, if the elements are not connected to each other, they are only simply sitting. If I bring, for example, a precast slab and I place it on the top of a beam without connecting it, then I can say that it's only sitting on it, or I can say it is simply supported. The slab is simply supported on the beam without having a proper connection. Now, if you are putting steel between these two, if I'm putting steel connecting the beam and the slab, you will see that this particular reinforcement is restraining the connection. The slab will not be easily going out from the beam because of the reinforcement, which is the same example of the glue and chair. Are we okay?
Yes, Mr.
Okay, so when it comes to simply supported two-way slabs, they will come only in two cases. Other cases are going to be restrained. Whenever I talk about regular construction, all of it is going to be restrained, except for two cases. Case number one is wherever we talk about precast without showing or without restraining, without putting any type of connection between the elements. If it's only a precast you brought from the factory and you place it in the site without making any connection between the elements, this is going to be called as a simply supported. And in most of the scenarios, precast elements are considered to be simply supported. Okay. Now, when it comes to the construction in the site, you cannot separate the elements from each other because you are putting reinforcement to connect the elements. So if you are putting the reinforcement to connect between the elements, then this is going to be a restrained connection. Okay, some kind of a fixity is there. The other scenario for simply supported is whatever we are going to see now. Okay, whatever we are going to see now, which is going to be representing a concrete slab sitting on a steel beam. Now, if a concrete slab is supported by a steel beam and there was no connection between them, you will see that the slab is acting separately and the beam is acting separately. And in this scenario, it turns to be a simply supported case. The slab is simply sitting on the beam only. So once again, we have two cases for simply supported action. Either it's going to be a precast element or it's going to be a concrete slab sitting on a steel beam without having any restriction or any connection. Now, the other scenario is where it's seen here. Now, can you see here this composite action? Can you see this composite action or composite slab? Composite slab is normally having a galvanized iron sheet, GI sheet, or whatever we call it, بالمتداول chinko, whatever we are having it here, the GI sheet. Now, above the GI sheet, we are having a mesh, and then we are having a concrete layer. Okay. Now, you can see this composite slab is sitting on a steel beam. And you can see here, can you see that there is there is a bolt? Can you see here that there is a bolt connecting the slab to the beam? Can you see that there is a bolt connecting the slab to the beam? Are you able to see it?
Yes.
Yes.
Okay, so now with the availability of the bolt, do you think that they will be connected to each other? The slab and the beam? If the bolt is there, will they still act?
Yes.
They will be connected, right? So if they are
Yeah.
connected, we should be considering it to be restrained. If there is no bolt, if there is no bolt, simply the slab is sitting on the beam, then it's considered to be a simply supported case, which is this one. Are we clear? Here we have a slab sitting on a steel beam. There is no connection. There is no bolting happening. So it acts like a simply supported case. If there is a composite slab connected to a steel beam by the means of bolts, then this is act as a continuous or restrained slab. Okay. Now, if you can see, if we go to our BS code, okay, if we go to our BS code, we can see for simply supported, they are telling us that this is the table you need to use. And here we have alpha span for X, and then we have alpha span for Y. Okay. Now, for a simply supported, if we want to draw the bending moment diagram here, can you help me in drawing the bending moment diagram for this case? If I take a line here, you will see that this is my slab, supported by a beam here, and this is going to be my bending moment here. And then here we have I took another line because it's a two-way slab. So this is going to be my span, this is my support, and this is my support, and this is going to be my parabolic profile. This is going to be X, MX, okay, because it's parallel to 4, and this is going to be Y, MY, because it's parallel to 6. Now, one thing to be taken into account, what is the meaning of S, which is shown over there? Okay, what's the meaning of S, which is shown there? We have span and we have support. So this S is representing the span. So the moment here is happening in the span, it's not happening in the support or path. Okay, Now we have alpha and we have beta, if you remember. So the code, just to differentiate between these two, between the restraint slab and then the simple slab, I mean the simply supported two-way slab. For simply supported two-way slab, they called the coefficient to be alpha. For two-way slab, they called it to be a beta. And we are going to see it now. Now, if you see here, so we have mx, and then we have my. Now, if we want to calculate this mx and this my, then first, as we said, we need to calculate alpha, which is the coefficient in this scenario, multiplied by w lx square, multiplied by w lx square. Lx square is always going to be there. Okay. Now we need to get these two coefficients. One is for x and one is for y. How to find them? We are going to use the table. Now, if you see the table, okay, keep these, delete this. Okay, if we see the table, now the table says for you ly over lx, and we have different values. Ly over lx is going to be equal to 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.75, and then 2. Why don't we have value more than 2? Because if it goes more than 2, then it's going to be a one-way slab. This is only for a two-way slab. It cannot exceed the value of 2. Okay. Now we need to get the value of ly over lx for this scenario. So now if we calculate ly over lx for this scenario, ly is 6, lx is 4, so it's going to give us 1.5. So we're going to go for 1.5. There are two coefficients. There is one alpha for x and there is one alpha for y. So now if I want to get the alpha for x, then it is going to be this value, which is 0.104. Alpha for y, it is going to be 0.046. Now if you want to calculate mx and my, you need to use the equation that we told you about, which is either n or w, and they are the same meaning. Okay, so you have alpha x, and then you have alpha y multiplied by w, which is loading, multiplied by your lx, which is short direction. Are we clear on how to find or how to use the table in order to get your your coefficient?
Yes.
Yes, Mr.
Okay. Now going for the bigger part. Okay, going for the bigger part, which is two-way restraint slab. Now, if you see, if we go to the code once again, if you see here, okay. Now you will see that we have different options. This is the two-way continuous slab. So we have interior panel, okay. We have one short edge, we have one long edge, we have two adjacent edges. Different scenarios are there. Okay. Different scenarios are there. So two short edge discontinuous, two long edge discontinuous, three edges discontinuous, three edges discontinuous, and then four edges discontinuous. You need to understand each one of them in order to pick the correct coefficient. If the coefficient is wrong, your bending moment is wrong, your area of reinforcement is wrong, and the full design is wrong. Okay, so you need to be very careful at picking the correct values. And then here you can see that there is beta. Okay, instead of alpha now, because it's a continuous, we have beta x, and then we have beta y. Now for you the the code is already available. You can see it. I have already uploaded it for you. Now if you can see, now when we talk about interior panel, what's the meaning first of an interior panel? What is the meaning of interior panel? Can you help me? Interior, what's the meaning of interior? What's the meaning of interior?
It's in the middle.
Okay, interior means it's in the middle. In the middle means, do we have surrounding slabs? If it's in the middle, do we have slabs on the side? If it's in the middle. So the first type, it is interior slab. It means that the slab is going to be at the middle. It is surrounded by other slabs. Like for example, if we go now to our slides, out of these cases, can we see a slab which is going to be which is going to be surrounded by all slabs from all sides? Can I say this slab? Can I say that this slab is continuous from this side, continuous from this side, continuous from this side, and this side?
Yes.
Is it interior now? Is it interior? Do you agree that this is interior now? It has slabs
Yes.
from all sides. Okay, so that's the meaning of case number 1. Can we go for case number 2? Case number 2 says for you, one short edge discontinuous. Now, how many sides normally? How many sides are there for the slab? How many sides for the slab? 4. Now it says for you what? It says for you one short edge is discontinuous. So it means 3 are continuous, but one short edge is discontinuous. Okay, so now we will go here. Now, for example, if we pick this, is this continuous? Is this side continuous?
Yes.
This side?
Yes.
This side? Is it continuous?
Yes,
Yes.
Mr.
Yes.
This side?
Yes.
So we have 3 sides continuous, only one side discontinuous, which is here. Do you agree?
Yes.
Is it short or long?
One edge.
Short.
Short. So is it correct that this is case number 2?
Yes.
Okay. Now going for case number 3. One long edge discontinuous. So how many continuous edges are there? One is discontinuous. So how many continuous are there?
3.
3 continuous and 1 discontinuous, right? Which one is discontinuous?
Long.
Long. Okay. So we'll return back here. Now, can I pick, for example, can I pick this to be case number 3?
Yes.
Can I say that this is continuous, this is continuous, this is continuous, this is discontinuous?
Yes.
Yes, Mr.
Okay. Everyone else, are we okay?
Yes, Mr. Everything is okay.
Okay, very good. Case number 4. What does it say, case number 4? Case number 4, it says for you, 2 adjacent edges discontinuous. Okay. 2 adjacent edges discontinuous. Adjacent means nearby. Okay. Or close. So when we say 2 adjacent edges, means one long and one short. Okay. One long and one short are going to be discontinuous. So here, 2 are continuous, 2 are discontinuous. One of them is long, one of them is short. And these are normally happening in the corners. If you see in the corners, 2 sides will be discontinuous. Now, if we return back to our case here, can we consider this case as number 4? Can I see that this is continuous, but we have 2 sides discontinuous, one is long, one is short? Do you agree?
Yes.
Yes.
Okay. So once again, it's very simple, but you need to concentrate. Okay. Now going for case number 5. Case number 5 says for you, 2 short edges are discontinuous. So there are 4. 2 of them are continuous, 2 of them are discontinuous. The discontinuous are 2 short. Okay, 2 short are discontinuous. So now when we return back, can we search for a place where 2 short are discontinuous?
Yes, Mr.
Where?
Will be the left and right.
Okay, which one here? Which row? Can you check?
I choose a new one.
No, which one is representing? We said, once again, we return back. We said, now we are talking about two short edges, discontinuous. Means two sides, which are short, discontinuous. So where are these?
Start on the last row.
Last row, and then?
Yeah, the first one.
You mean this one?
Oh, the one on the top.
On the top here?
Sir, in the middle, at the top, at the middle.
And the middle, this one?
No, in the middle and down slabs, word slab,
Here?
down, that one.
Here?
No, up, sir. Same row as 4.
Okay. So why not to have this? Is
It
it
is
it
one
discontinuous?
only, not
Okay,
connected.
one minute. Is it discontinuous from this side? Do we have a slab on the right side?
No.
No. Okay.
No.
Do we have a slab on the left side?
No,
What is this?
it's opening.
What is this? What is this X?
It's opening.
It's an opening. So if it's an opening, do we have a slab?
No.
No. So how many discontinuous edges are here? How many discontinuous?
Two.
Two. And how many continuous?
Two short.
2 continuous, 2 discontinuous.
Okay, so the continuous are the long, the discontinuous are the short. Is it now case number 5? Do you agree, all of you?
Yes.
Okay. Now going for case number 6. Case number 6 says for you two long edges are discontinuous. Can we return back and help me here once again?
Above number 1. Mr.
Above number 1.
No.
Do you have above number 1? Do you have what you call? Do you have both long?
Fourth column.
Which one? Which one?
On the right of 4.
On the right of 4. So if you see the right of 4, as your colleague said, this is going to be number 6.
Yes.
That this is discontinuous from here. It is discontinuous from here. It is continuous from here, and it's continuous from here. Right? So we have two edges which are long and discontinuous, and two which are short, continuous. Do you agree?
Mister, could you repeat 6, please?
Yeah. Now number 6. Number 6, if you see, this is number 6. Do we have on the top side, do we have any continuity, any slab? Any slab above number 6?
No.
No. So there is no slab, it's discontinuous. What about at the bottom? Do we have a slab or is it an opening?
Opening.
Opening, so it's discontinuous, there is no slab. What about the right side and left side?
Continuous.
Continuous. So how many continuous and how many discontinuous?
2 continuous and 2 discontinuous.
Now the discontinuous, are they long or short?
Both of them short, continuous, and
Okay.
two both.
Too long?
Yeah.
Okay. So the case says two long edges discontinuous. So is it the correct one?
Yes, Mister.
Okay. Now going for case number 7. Case number 7 says for you 3 edges are discontinuous. Only one which is continuous. So 3 are closed. 1 is opened only, which is one long. So once again, 3 are discontinuous. Only one is continuous, which is long. Now, can you help me here finding it?
Mister, between three openings.
Between the three openings, which side, which column, which row?
Row 3, the middle row.
Okay, so we are talking about this one.
Yes.
Okay, so now if you see, there is an opening here, so there is no slab. There is an opening here, so there is no slab. There is an opening here, so there is no slab. Only there is one slab on this side. So three are discontinuous, only one side which is continuous, and that side is long. Are we clear?
Yes, Mr.
Clear? Anybody with any question? Okay. Now case number 8, let's go for case number 8. Case number 8 says for you, three edges are discontinuous. Only one short edge is continuous. So three are discontinuous. One is continuous, which is a short edge. Okay. Now we need to go here and once again help me in finding it. Can you help me in finding number 8?
Fourth column, Mr.
Fourth column, which is coming here. Right?
Yes.
So here it's discontinuous because it's an opening. Here it's a discontinuous because it's an opening. Here it's discontinuous because it's an opening. Okay? It has only one continuous, which is short or long.
Short.
Short. Now last type, it says for you 4 edges are discontinuous. All the 4 sides are discontinuous. Can you help me in finding it?
Down, near to 8. One row down on the right.
So
Yes.
this one,
Yeah.
can we say that this is discontinuous from here? It is discontinuous from here because of the opening, discontinuous from here. And then can we have discontinuous from here? Okay, and there are other slabs which can be either one of the cases as well. Okay, the others, they have even the same categories, but this is only an illustration for you for the categories. Are we okay? Are we fine?
Yes, Mr.
Okay, so now if I go,
Yes.
for example, if I go and take this one, mm, so now if I'm having these particular slabs, and I wanted to draw the cases. So now if we talk about case number 1, case number 1 is this slab. It is continuous, 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 and continuous. Do you agree?
Yes.
Do you agree? Okay. So now if I want to draw the bending moment diagram, I'll just draw a line here. So this is my line. There is a support here. There is a support here. One support. One support. Do we have slab on this side? On this side, we have slabs. So we are going to draw a small extension. What about here? This line. There is a slab here. There is a slab here. So I'm going to draw another line. This is an extension. And this is another extension. Case number 2. Case number 2. Now, if you see case number 2, what do we have? we have 3 edges continuous, only one which is discontinuous. Okay. Now if I try to draw a line here, you will see that there is continuity on these sides. So if I want to draw the bending moment diagram, here it's discontinuous, here it's continuous since there is a slab. On the other side, this is my slab. Here we have a slab, here we have a slab, so there should be an extension. Case number 3. Case number 3. Now you see case number 3, what do we have? We have this type of slab, and then there is discontinuous here. If we want to try to draw, so I'm going to draw here, continuity, continuity, and then continuity. Okay, if I want to draw the slab bending moment, so here it's discontinuous, so no need for extension. Here it's continuous, so there will be an extension. Another line here, so there is a slab, so extension. There is another slab, so extension. Okay, now to draw the bending moment, as we said, now since this is continuous, it goes up, down, up, and then down. Up, down, up, and down, since these are continuous. Now for the discontinuous, it starts from 0, as we said. It goes up. Once again, it goes up, down, up, and then like this. For here, it goes up, down, and then up. For here, it starts from 0, so 0 up, and then down. Now if you want to simplify, and you want to check your answer is correct or not, what we can do, we can draw. Okay, we can draw a line. So for example, I want to draw a line here, representing the slabs. So if I want to draw a bending moment, you will see that this will go here, it will go here, it will go here, and then it will go here, and then it will stop because there is no slab. Do you agree with me? This is in the first direction. Now in the second direction, in the second direction, in the second direction, okay, in the second direction, I'm going to draw a line here. For one, I'm drawing for one now. So I take a horizontal line, and I have, now I'm drawing the vertical line. So you can see that this is starting from 0. It goes up, it goes up, it goes up, and then it goes to 0. Now if you see, okay, now if you see case number 1, if you see case number 1, this is case number 1. You will see in the horizontal it's continuous, or it's looking like this. In the vertical it looks like this. Now if I go to the strips that I have drawn, you will see it's a representation of this one. Now what about case number 2? You will see, or case number 1 in the vertical, you will see it represents the same. Now if we go, for example, for case number 2, you will see this starts from 0, it goes up, it goes down, up, up till reaching 0. On the other side, for 2, if we try to draw the bending moment vertically, you will see that it starts from 0, here, 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 and then it turns up to 0 wherever it's discontinuous. Now if you can see 2, it is a representation of this bending moment in one direction. It is a representation of bending moment, of this bending moment in the other direction. So you can see it now here. that it looks like this in one direction, it looks like this in the other direction, which are here. Can you see? Is it clear? Have you understood the concept of drawing the bending moment diagram?
Mister,
Yes.
could you please draw the bending in the second row?
Which second? Or which slab? Which slab?
Mm,
Slab 7 and 5, you mean?
yeah.
Okay. So if you want to draw, first this is the slab. So I'm going to draw a line. Second, there is no slab, so no need for a line. 7, there is a line, and then we have a line. Wherever there is no slab, there is no line, there is no bending moment. Okay. So this is going to be your bending moment shape. All of them are discontinuous in this side. Right? Do we have any continuity for 7 on both left and right? For 7, do we have any continuity if you see 7? Do you have any continuity on both right, left and right?
No.
No. So it needs to be simply supported, right? It tends to be discontinuous from both sides. What about 5? Do we have continuity from left and right?
No.
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 So once again, it tends to be a discontinuous and the bending moment is equal to 0. Okay?
Mister, I
Yeah,
have a
finish.
question.
Yeah, okay. So first thing, we have finished the session. Those who are not having any question, they might be having a class. They are free to leave to their class. Others, if you have any question, you can ask. Yes, ask me, please.
Yes, Mister, if you bring this whole slabs, you will
Okay.
ask about drawing the bending moment, right? So
You
we have
could
to
be-
draw each
You
row.
could be asked anything. Anything.
So if you ask about drawing the bending moment, so we
Okay.
draw each row, right?
If
So
I
we
ask,
go through each
if I
row.
asked you, yeah, if I asked you to draw for all, then you will be drawing for all. If I asked you to, for example, if I asked you first select or identify case number 5 and case number 7 and then draw for me the bending moment for these cases, and first you should know where is 5, where is 7, and then draw. Or maybe in this semester I might ask you that I need you to draw for me a plan in which the 9 cases are there.
So if all that's mean Y and X, we should draw, right?
What?
If you ask for all bending moment, we should draw Y and X.
Yeah, both. If it's two ways, both, of course, we said. That's why I'm
Okay.
drawing for each and every case, whatever I have finished, I'm drawing 2. Because this is assumed to be a two-way slab now. If it's a one-way slab, it's only one side drawing, as we said. So next class, we are going to have further problems in terms of drawing the bending moment, in terms of finding the coefficients, and we'll start directly the problems or the numerical problems. Any question? Any other questions that you are having? Any person? Any other question?
Thank you, Mr.